First, we have 3 different ways that we can measure central tendency. So that's basically like looking at different ways of looking at your average. So there's different averages. Normally, when we talk about average, everyone thinks we're talking about mean, but there are lots of different types of averages. So let's start with the first one. We're going to start with mean. What is mean? Yeah, that's perfect. It's the sum of all the numbers divided by how many numbers there were in the data set. So when we have a symbol for mean, and you'll see it on your calculator, it looks like this. So it's an X with a little line on the top. We also sometimes call this average, but we got to be careful with saying average because there are different types of averages. And what your mean is exactly what was said. You sum up the data and you divide it by the number of data. Okay, so if we had to write this the fancy way, we are going to write it like this. And let's see if we can figure out what these different terms are. Hi, Boo. What does this term mean? That funny looking E. Good. The funny looking E stands for sum of. X is talking about your data. And N is talking about what? Yeah, it's talking about the number. And this dude is on your formula sheet. But remember, your formula sheet is only useful if we actually know what the formula is meaning. So it's important that we know what these are meaning. If at any point you don't understand something, please tell me to stop or tell me to slow down. I want to make sure you know this because this is a section I think everyone can definitely do very, very well in. Okay, let's look at the second one. What is the median? Yeah, good. Okay, so the median is your middle value. If I say it's the middle value of the data, or like where you're saying it's the middle number, what is like something I would have to do before I could look for the middle number? Because if I just had like a list of numbers that were given to me, can I just choose the one that's in the middle? So let's say I had numbers like this. So 10 to 31, 6, 4, 12. I'm going to do another 6. Good. Okay. I can't just choose my middle number. I can't just be like, okay, cool, that's my median. The first thing I have to do is I have to order it. So the first thing I have to do is sort the data from lowest to highest. And then I can get ascend to the moon, then I can get the middle number. If we have a whole bunch of numbers and I don't want to have to count through all of them, the way we can get the position of that number, remember this isn't the middle term, it's the position of the middle term. We can say n plus 1 over 2. So let's have a look at this example over here. So my n is 7, because I've got 7 terms there. So 7 plus 1 is 8. 8 divided by 2 is 4. So it would be term 1, term 2, term 3, term 4. But remember, we would first have to order these. So if I first ordered it, it would be 2, 4, 6, 6, 10, 12, 31. And look at that, our median lands at being 6. Anyway, how fortuitous. So term 1, term 2, term 3, term 4. Good. So this would be term 4, which would give us our 6. But be careful, this is the position of the middle term, not the middle term. Did I do stats with you for one lesson? Well, good. Maybe it's all stuck. Okay. Next one. Our mode. Oh, wait, hold on. Actually, let's talk about our median quickly. What if I have something like this? So what if I have 2, 6, 7, 9. Let's keep it like that. What if I only had a list of 4? How would I find my median? Because my median should be somewhere in there. Good. When we're in that situation, we add those two middle terms. So we would say 6 plus 7 divided by 2. So my median would be 6.5. Okay. All right. Let's move on to our mode. Good. The number that appears the most frequently. So it occurs the most. Now the mode is, there's like two things we got to take into account with it. The one is we can have more than one mode. We can also have no mode. And in grouped data, which we're going to look at just now, we have something which is called the modal class. Okay, so we've got different options. So who can give me an example, like a list of numbers where I would have more than one mode? Give me a list of numbers where there is more than one node. Mode. This is node, mode. Any list, any random list. Yeah, there we go. And we've got multiple ones. So if I had something, it's totally fine. If I had like 2, 4, 5, 7, 4, 9, 5, I've got 2 4s and I've got 2 5s. So I have 2 modes. My one mode is 4, my second mode is 5. I could have no modes. So if I had like 2, 4, 9, 12, 14. There's no number that occurs more than once, so I have no mode. And in group data, that's something we are going to look at just now. Does anyone have any questions about anything that is on the screen right now that doesn't make sense or you'd like to be explained a little bit more? This is your time to ask. And if not, please, if you'd like, take a screenshot and we can move down to histograms and frequency polygons. We all good? Okay. Okay. Okay, yeah. So modal group is what we're going to talk about right now, Lutendo. I'm glad that you asked that question. So when we have group data, which is what we've got happening over here, we can have a modal group. And I'll show you what that means. So what we are looking at over here is grouped data. If you have a look at this table, and I'm telling you it's group data, what do you think group data means? or like give me some kind of explanation from what you're seeing. Yeah, good. It's working with your data set. Go, good. Data that falls into a range. So because this is a range, we don't have like an exact number. It's somewhere between 0 or 20, or somewhere between 20 and 40, somewhere between 40 and 60. So our data is grouped. It's not exact. I don't have an exact number of who was 10, who was 20, who was 30. It's grouped. So this part over here is what's telling us that it's grouped. So we've got data that falls into a range of things. When we have grouped data, we have to do a couple of things. We need to find the midpoints of the range to get an estimated mean. So it's not going to be exact. It's going to be an estimated mean. We'll talk about that now. So let's have a look at these. What would be our midpoint between 0 and 20? Yeah. Okay. Good. And 20 and 40. There we go. 40 and 60. And 60 and 70. Oh, I've said it already. And then we've got 90. Okay. So to answer the first question that came through about the modal group, if we had to look at these, which one of these groups of data has the most number? Like which one? Yeah. Okay. So this one has 20. So if I had to have, I can't have like a mode. I can't have a number because it's within this group. So what I would say is I have a modal class of 40 to 60. We're going to answer that question just now, but I just wanted to answer what was asked in the chat. Okay. Cool. All right. So let's work out our totals in order to figure things out. When we're trying to figure out our total value, this is so that we can eventually work out our mean, we take our midpoint over there and we multiply it by the frequency to get our total. So what we're saying over here is 10 times 8, which is giving us a total of 80. Yes, the answer depends on the frequency completely. Yeah. Then for our next one, we're going to say 30 times 15, and that's going to give us 450. Then we have 50 times 20, which gives us 1,000. 70 times 18, which gives us 1,260, and 90 times 10, which is 900. So this is what our frequency table is looking like. Okay. For the moment, we're going to leave this here. We're going to answer more questions on it just now. But what I would like you to do, I'm just going to minimize this a little bit so that I have space. Is you are going to take this information and you are going to draw a histogram. No, so someone didn't score 900. That's total of all of it, because we're taking what their marks were and we're saying 10 people got about this. So between the 10 people, they got about 900 altogether. So it's like an estimate of what the total is of those 10 people. Okay, let me explain this a little bit more, just so that it's like super duper clear. So the top row is looking at our mark, right? So let's have a look at this first one. So 0 to 20. This is saying that we have 8 people who got between 0 and 20% in their maths test or maths mark of, yeah, there were 8 of them. Now, I don't know what each of their marks were. So to get an estimate of what all of their marks were, all of those 8 people, if I wanted to add them up together, we take this midpoint, which is 10, and then we multiply that by 8. So we're saying if we added together all of those 8 people's marks, we think we're going to get around 80. So it's completely an estimate. If we take the people who got between 20% and 40%, there were 15 of them. We're saying if we added all of those 15 marks together, we think we're going to get about 450. So that's where these are coming from. And we have to do it like this in group data because we don't have the exact numbers. So we can't be super precise. We can only do estimations when it comes to group data. Okay, so the first thing you're going to do is you're going to draw a histogram with this data. The most important thing with a histogram is that we have no gaps between the bars. So our bars need to be touching and we need to have labels. So draw yourself a histogram on your side. We're going to need it so we can answer some of these questions. A histogram is like one of those bar graphs, but all of our bars touch each other. So like that. So if I you're just going to have to be kind with me, guys. My lines are not super straight. So I would start by saying like this group here is when I have from 0 to 20. And then I'm going to have markings up here. So let's say 2, 4, 6, 8, 10. And then down here, let me actually make it a little bit bigger. I'm just going to make it like every 3. Okay, mine is not beautiful, so please make yours nicer than mine. So something, I'm just going to draw the first 2 bars so you get an idea. Something like that. Okay. Let me know when you're done in the chat so that I know when to carry on. Or if you are absolutely nowhere, not too sure what you're doing, please let me know. We are going to do standard deviation. I'm going to show you how to do some things in your calculator to make your life a little bit easier. We're going to do cumulative frequency graphs, all kinds of things. Yeah. Exactly. You're old now. No more bar charts and pie charts. Now we get into the big stuff. Okay, don't forget to let me know when you finish with the histogram in the chat so that I know when you're done. And please excuse my very, very messy histogram. I will try and fix it up while you guys are working. You remember being in grade 1? I don't remember being in grade 1. I suppose I do. I remember my grade 1 teacher. But I'm quite a lot older than you, in fairness. No, man, finishing school is fun. That's when you get to start doing like cool stuff and you can go and study. You can become famous sports people and pay for my retirement. These are all options you're allowed to have. Oh my gosh, Nelly, that is so mean. Grade 1 teachers are all supposed to be super nice and friendly. Can you see it? You don't need to have a key for this one because you only have a key if you're comparing things. So like if I have a double bar chart, and so some were like lined like that and others weren't, then I would need to have a key. But because we just have like one single sort of type of data that we're showing, we don't need to. Great question though. Okay, I'm going to give you guys 2 more minutes on this one, because then we have to start looking at the histogram so we can answer questions. So generally, you only have a key. You'll have a key in a pie chart, but it's very unlikely you'll have to draw a pie chart or pie graph. And in a double bar chart or a stacked bar chart. Yeah, so like in maths, you definitely won't have to draw a pie chart. I remember a few years ago, it was probably about 5 years ago now, there was in the life sciences exam, they asked, it was in the matric final, they were asked to draw a pie chart, and they're like, and no one had like their compass or protractor, and it was a disaster. Hi, Leander. Oh, you have to draw them in life science now. Well, let's just take this as a warning and make sure you have all that stuff when you go into a life science exam, just in case. Because they always say they're never going to ask, and then the one year they did. You'll be fine. Okay, I'm just going to carry on filling this in. Leander, I will go to the top of the lesson as soon as I'm finished this histogram, so you can take a screenshot. Trying really hard to have straight lines here, but I'm struggling. All right, that's what you have missed so far. Okay. So our goal was to draw a histogram. The second one is use your histogram to determine the modal class interval. So now that's exactly what we just spoke about. All that this means when it says modal class interval is the group, in this case, our mark percentage, with the highest frequency. And if you're looking in your histogram, it's the one that has the highest tower. So we can see that in our case, that is in our 40 to 60 range. Okay, now we get to a fun question that I'm curious to hear how you think we're going to do this. C, give an estimate of the mode. So remember, when it was a mode, it's the one that is the most frequent. And they're asking us to give an estimate. What do you think our estimate's going to be? Aha, Yanda and Uya coming in strong. Yes, exactly. We're going to take our modal class. We're going to take this dude. We're going to add them together and we're going to divide by 2 because it's an estimate. So we're going to take the modal class, the 40 and 60, so the lowest and highest part of our modal class. We divide it by 2 and we get 50. Anyone not understand that? Please let me know. Like I said in the beginning, just for the latecomers, data handling, statistics, and like probability, they are really nice sections to have guaranteed marks because the questions are all pretty much the same in every year, every exam. So I really want you to be able to do super well in this section. If you have questions or if there's something you don't understand, please, please, please tell me so that we can all like guarantee 100% with your stats. Okay, cool. D, use our graph to determine how many learners got a mark less than 80%. Okay, I'm going to let you think about that first. Just going to highlight one little thing for you. That's oh, this wasn't a test. This is just, these are just questions. But in general, in tests or in your exams, it's a section which is really, really easy to get 100% for. So like when you get into your maths paper 2 exam, I want you to start with the section and smash it, get all the marks, and then you can carry on to all the sections that you don't like. Oh, Yanda. Came late, but coming in strong. Yeah, stats is always question 1. So Yanda, how did you get 61? How do you get that as your answer? No, can you see it? So how did you get 61? I'm happy with the answer, just so you know. It's the right answer. How did you get there? Good. Beautiful, Uya. Okay. So this is the only bar, this bar over here is the only bar where students got 80% or more. Which means that this bar over here and this bar over here and this bar over here and this bar over here were all students who got less than 80. So all we have to do is we take their numbers. So we have 8 plus 15 plus 20 plus 18. So 8 plus 15 plus 20 plus 18, and that gives us 61 students. 100% you can do that. Add the ones that are on the table. Perfect. Okay. So this question was given to you to set up the next question. So the next question is, in which interval, so that's talking about which one of these groups, like that, in which interval does the median lie? So remember, for the median, think about the position of the median. That's my little hint to you. So they don't need to know the number of the median. They just want to know in which interval or which group the median would sit. We're just taking shots in the dark here. Okay. So remember, to find the position, we take the total number plus 1 and divide it by 2, right? So this 61 takes us up to here. So we have to add 10. So our total number is 71 plus 1 divided by 2. And this gives us our position. So 72 divided by 2 is the 36th position of our frequency. So we think, okay, there's 8. If we have 8 plus 15, that's going to take us to 23. Then we're going to add another 20. That's going to take us to 43. So 36 is going to lie in here because it's going to be from position 24 to position 43. So it's going to be in this range. Again, please let me know if that doesn't make sense. So we're just looking at where, if I have to write out all of those, absolutely, I'm happy to explain that again. Let me just erase this. Okay. So, are you happy with this, the position of the median, where that 36 is coming from? Okay, so we have 71 data points in total, and we're looking for position 36. So imagine if there are 8 positions here, imagine that's like saying I've got person 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 dot points there. So I'm going from 1 to 8. Now in here, I've got another 15 of them. So that's going to be person 9, person 10, person 11, blah, 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 all the way to person 23, because there's 15 of them. Then I have another 20 in the next one. So now this is going to be person 24, 25, 26, all the way to person 43. So if I'm looking at where is person 36 is going to be somewhere in here because it started with person 24 and it ended with person 43. So I know that 36 must be in that range. Yes, medium, no. Okay. I'll take that. Okay, next one. Another question that seems to like completely trap learners. Oh, well, now you know. Can you see it? So there we go. We're all learning. It seems to trick people, and it's not supposed to be a tricky question. Draw a frequency polygon on your histogram. To do a frequency polygon, all we have to do is we have to put midpoints on our bars and join them. So, for example, let me do it in a different color, a little darker color. So that's a midpoint, that's a midpoint, that's a midpoint, that's a midpoint, and that's a midpoint. And all we have to do is join our midpoints. And that is your frequency polygon. So Leander, technically that is what you're doing because you're sort of finding, but like when it comes to a histogram, because we're looking at it as group data, we can't find the medians for all of those. And so we just estimate. So we just give middle point values. You know what, Ayanda, that is a great question. And I actually trying to remember if you do. Yes, you absolutely do. Do you? Now I'm questioning myself. Does that look more right or does that look more wrong? No, I feel like you don't have to do that. Oh, you've got me questioning my entire life. I'll double check. For the moment, I'm going to say no, but I'm going to double check while you do the next little thing to make sure that I'm not telling you the wrong thing. Okay. While I double check that, there is 2 questions for you to work on. So G, which is what does the frequency polygon tell you about the maths mark? And H, to determine an estimate of the mean mark, which we've actually done all the hard work for that already. It tells you things. It can tell you things. So from what I can see, it doesn't look like you have to ground them. So I'm going to stick with this for now, but I'm going to double check. I'll do some more research and I will just make sure that that isn't the case before our next lesson. But from what I can see, it looks like we're fine. Okay, Uyanda. Most math learners got a mark in the range of 40 to 60. Half the learners that got the most common mark got the highest. Okay, cool. I like that. You've got the estimate of the mean. Yeah, I mean, I got 59.97, I think. So I think we're on the same track. Oh, no, yeah. So Kimberly, we don't need to do that for a frequency. We do that for the cumulative. Yeah. The frequency one is super nice and easy. Like the frequency one is like our happy graph. We just have to take our midpoints, connect them, and we're good to go. It looks like if you wanted to ground them, you would have to have another section over here because we can't ground to 0. We would have to have another grouping over here. And then you would group this next one in the same way. So you would have like a midpoint down there because you've technically got no values in that. So if you're wanting to ground it, that's what that would look like. Don't worry, we're going to get to cumulative graphs. You don't need to worry. We're going to get there together. So for G, there's lots of things you could tell me. You could say, we've had some great answers in the chat. Really, all we need to say is that it's symmetrical about the median. Because we know that the median is here, and we're getting like a nice little curve. So it's sort of symmetrical. But Uyanda, you had a great answer there. To do your estimated mean, you have to add up all of these totals and then divide by the total number of learners, which was 71. So we would say 80 plus 450 plus 1,000 plus 1,260 plus 900. And you're going to divide all of that by 71. And I got 51,97, but I think Abu got a slightly different one. Okay, you had the same. Okay. Now, finding your estimated mean, you can always do it this method. You can always do it this way. However, sometimes that's quite a pain. So I'm going to show you how you can do it on your calculators. We're going to write it down. Or it doesn't have to be a whole number. You can keep it to 2 decimal places. Okay, so please let me know. Mean is where it's like the most commonly word for average, even though there are different averages, but mean is when we have the sum of all of our numbers divided by the number of data points that there were. Okay. Step 1. Turn on the frequency table. Leander, are you saying as in for the definition of what a mean is? Okay, so in this, it's an estimated mean because we were working with group data. But if I just had like a normal string of numbers like that, and I wanted the mean of those numbers, I have 4 data points, and I would add up their sum. So I would say 1 plus 2 plus 4 plus 6. So I would have 13. I'm dividing that by 4 because there are 4 number points, and that would be my mean. So it's the sum of all your values divided by the total number of points. In the grouped data, it's slightly different because grouped data, we don't have the exact numbers. When we're doing an estimated mean with group data, we first have to get these total values, which was the midpoint of the group times by the frequency. So that's where we got our 80. The midpoint 30 times the frequency, which got our 450. So we're adding all of those together. So that's like adding all of our data points together to get that total. And then we know we had 71 people in this. So that's the number of data points. So we have our sum, which is an estimated sum, which is why it's an estimated mean, divided by the number of people in the study. You're welcome. Okay, let's turn on our frequency tables, and you can keep this on always, so you don't ever have to turn this off if you want to. So you are going to click Shift, and then Setup should be sort of at the top right. And then you want to scroll down. So you're going to use your arrows. So like use your little arrows or your wheel, depending on what your calculator is. And you're going to scroll and look for stat. So on my calculator, stat is number 4, but it might be different. I think on some of yours, it will be number 3. For me, it's number 4. So for me, it's 4, but it might be 3. Have a look and see what it is for you. And then you're going to want, it's going to give you a question. It's going to say frequency, and then on with a 1 and 2 is going to be off. So we're going to click 1 so that it's on. So step 1, step 2, step 3, step 4. If anyone's struggling with that, please let me know. And if at any point you want to get out of stat mode, just press mode 1. Okay. Can you give me a thumbs up when you've got that done so that I know how we're doing? Thank you, Uya. Thank you, Alec. Okay. Now, if we wanted to do this estimated mean on our calculator, okay, so mode. So you're going to click mode. And then you're going to click stat. So for me, it's number 3, but for you, it might be number 2. So wherever your number is for stat, you're going to click that. And then we're going to click 1, where it says 1 var. So you're going to just click the number 1. And then you're going to start inputting your variables. So you're going to input your data. And after you input a piece of data, you push the equal sign. So in our case, because what you should have on your calculator now, it should look something like this. X and then freak and 1, 2, 3. It should look something like that. So for X, you're going to write this middle point that you had over here, so the 10. So you would write 10, and we had a frequency of 8. And then 30, and you had a frequency of 15. And 50 with a frequency of 24, which is 70 with a frequency of 18. And the last point is 90, and that had a frequency of 10. Okay, so you're just going to input that into a calculator exactly like that. And you can use your little arrows to make sure you can get to the frequency. Okay, so it should look something like, oh, it's so blurry, like that on your calculator. Okay, cool. And then you're going to push AC. So it like clears your screen. And shift 1. And then it's going to give you a whole bunch of options. And we're going to say 4 for var. So you're going to push 4. And then it's like giving us different options. So it's asking about the standard deviation. It's looking for the total number. And then for the mean, we want the mean. So we're going to push 2 because that gives us the mean. And then you just have to push equals. And you should get 51.97. Well, I should hope it works. I know that this looks like a lot. Don't worry. I think I don't feel like you are like need to memorize this. I promise it gets easier over time the more you use it. So Kulani, probably what happened was it was just a number that got inputted incorrectly. It's also just like a nice way to check that you know you're correct. But please take a second to give it a try on your side so that I can help you with your calculators if you can't get it working. I'll zoom out a little bit so that you've got it all on one page. So this is asking for your mean. Yes, the answer is 51.97. The magic of the calculator. You can also do other things with it. So for example, if you push AC now, and then you push shift 1, so that takes you to your stat mode. Let me write it up here as I'm talking. So all I've done is shift 1 so far to get into my stats mode. And I'm going to go back to 4, which was my var. And then let's push number 1. So N is telling us our total. We know that the answer should be 71. So push it, make sure you get 71, then you know you're good to go. And you can clear it again. You can try the other things. You can look at your min and max. You can look at your mode. It does all of that for you. It's like a magic little magic is what it is. Yeah, your calculators are cool. They do some cool things. Once you've put in the data, so like all of this part over here is actually inputting your data. And now the data that you have in there is locked until you rechange it. So until you put more data, that data is going to stay there. And then this system over here is like the quick bit. So if you push Shift 1, that's always going to take you into stats mode. And then you can just kind of go to where you need to go to from there. I'm telling you, your calculator is your best friend. It does all sorts of cool things. And if you get the white calculator, like this one, then it does all your factorizing for you, all your trinomials. No, so Sanela, you don't always have the frequency part, so that one is for group data. But when we do ones that aren't grouped, I'll show you how to do that. Well, it's not really cheating because you're allowed to have the calculator in the exam. Okay. Take a screenshot of this so that you don't lose it. Yeah, can you see, Leah, if you get the Y calculator, let me know, and I will write down the steps to help you do all your factorizing for you. You have to have the Y calculator if you do AP maths. So those students have it anyway. So why not also benefit? Well, it does, when you get into calculus, into matric, it does lots of things in calculus. Makes your life much easier with calculus. Okay, I'm sorry. I know this is not the best image. It didn't copy through nicely. We're just going to do the best we can with it, though. Okay, so first things first, let's have a quick read through. The following frequency polygon. You see, now this one's grounded. Now that's making me question everything in my life. Oh no, it's grounded because there was space on each side. Okay, now I feel better. Okay. The following frequency polygon shows the mass in kilograms of a group of grade 11 learners. The figures have been grouped in intervals of 10 kilograms. So it's between 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90. Use this figure to answer the following questions. How many learners are there in this group? If you can't see the numbers beautifully, let me know and I'll help out. But have a look at where the arrows are pointing to help you. So there are 5 groups, but in the first one, so for A, I've got 22 who are in the first category. Then I've got 30 who are in the second category. In C, I've got 26. In D, I've got 8. And in E, I've got 5. So how many learners are in the group? I've got 22 plus 30 plus 26 plus 8 plus 5. Yeah. Okay, so I'm just going to write these numbers like near them so that it's a little bit clearer for you, because I realize the numbers are not super clear. For the second question, how many learners have a mass greater than or equal to 60 kilograms? And if frequency polygons scare you, just think of them as a histogram. Beautiful, 39, absolutely. Good. So we have 26 plus 8 plus 5, which gives us 39. Yeah, I know, for some reason, frequency polygons look scary, but like histograms don't. So if you just make it into a histogram, it looks a little bit less scary. I don't know what the logic is behind that, but it's true. Okay, in which interval does the following lie? So where does my median lie? So remember, look for the position. And then think about where that would fit. Let's see if we get a few more answers. Also now, if you go into your calculators and you push your fraction key and it looks weird to you, it's because you're in stats mode. Remember, to get out of stats mode, you just need to push mode 1. Okay. Just so I don't want you to panic if your fraction looks like that. Okay, let's have a look. So to find the position of our median, we would take our total number, so that's 91, plus 1 divided by 2. So that gives us 92 divided by 2, which gives us 46. So we're looking for position 46. So in this first category, so over here, in the first of our histograms, we have 22 learners. And then in our next one, we've got 30 learners. So at the end of these two histograms, like if I had to draw this as like a little graph, so in my 40 to 50 range, I've got 22. And then in my 50 to 60 range, I've got 30. After this point, I'm going to be sitting on 52 learners. I'm looking for position 39, which means it has to fit somewhere in here. So my median is somewhere between 50 and 60. Where's your 39 coming from? What are you trying to answer with 39? Are you answering the previous question? Oh, so Abu, the comp stands for computation, which is basically just like a fancy word for like math mode. Oh, where I got the 39 from. Okay. Okay. So for the 39, it was asking how many learners have a mass greater or equal to 60 kilograms. So let's actually just, to make our lives even easier, let's fill this out a little bit further. Because it seems that you are all much more comfortable to work from the table. So let's just make our own little table. So we have 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90. Okay, and we've got 22, 30, 26, 8, 5. So the question was, how many learners have a mass greater than or equal to 60? So it's all of these three, because they have a mass of 60 or more. So we're just adding the 26, the 8, and the 5. If you find it easier to work from a table, just draw yourself a little table. There's no judgment here. Yes, the upper quartile is quartile 3. So when we're looking for quartile 3, quartile 1 would be 1/4 times. Quartile 2 is, so like, for example, what we're saying over here is, because the median is the middle point. So basically what we're saying is a half times n plus 1. Quartile 1 would be 1/4 times n plus 1. Quartile 3 is 3/4 times n plus 1. So we're saying 3/4 times 92. Which gives me the 69th position. And then we just have to figure out where that would fall. So up to here, that takes you to 52. If we added another 26, that would take me to 78. So that would fall in over here. So I would have between 60 and 70. Exactly. Yeah, so no, the median has nothing to do with, oh, no, it's the median. No, the median doesn't have anything to do with 39.